Welcome to Module 2, which is forecasting of the production and service system planning part 1. So, in the first part, we talked about regarding what is forecasting, why it is important, as well as what kind of forecasting methods we can use. So, we mainly differentiate the forecasting method in terms of qualitative, which we discussed in the first part. That is basically the market survey as well as the Delphi approach. And then we briefly talked about the quantitative method, which is a forecasting method, that is a causal based forecasting method, as well as the time series forecasting method, as well as we discussed about the hierarchical production planning decisions. So in this video, we are going to start talking about how we can predict the time series forecasting, as we know that which we have discussed in the last part, that it is based on the one variable, which is basically the time. Okay, now first of all, let's discuss how many time series forecasting data we might have, and then how we can predict it. So mainly there is a two type of a time series forecasting data. So one I am calling it as the fast demand, another I am calling it as a intermittent demand. So when we are saying the fast demand or the fast sales data, which mean there is no missing value, or you can say the demand is occurring against the every time period we are considering, whether it is a daily or a weekly or a monthly. But generally, in a fast demand, the data is monthly or a quarterly or a annually basis, which is generally in case of the aggregate demand, which we have discussed in the part one. What is the aggregate demand mean? Which mean when we would like to predict the product family level demand. Okay, but if I am talking about the individual product level or the individual SKU, which is a stock keeping unit, in majority of the cases, there might be possibility we are going to face the intermittent demand pattern, where we may have the demand occurrence and where there is a time where we do not have any demand, which means it is equal to zero. So there is a demand occurrence and there is a zeros. Okay, so which means intermittent demand. So in a certain time period we have the occurrence of the demand, and in a certain time period we might have the zero demand. Okay, so that time period, such time period or the such time series is known as the intermittent time series or the intermittent demand time series. So in this video lectures, we are going to cover only the fast demand time series forecasting method. If we have this data pattern where in every time period we have the occurrence of the data or occurrence of the demand, so how we can predict it. So in order to predict this kind of the fast demand data, we first of all need to check the pattern of the data. Okay, so that means every time series data have certain pattern plus the random variation. So when we are saying the random variation, which means we are talking about the forecast error. Okay, or you can say the error in the error which we have predicted using the historical data. Okay, so which means what we want, we would like to accurately predicting this pattern, whereas our forecasting method must produce this minimum error. Okay, so that forecasting method is going to be the best forecasting method, which is going to produce the smaller and smaller error. Okay, but in order to identify what kind of pattern, so we can divide this pattern of the data into the three part. One, it is called as level. So what is the level mean? If I have the data, which mean on x-axis we have a time, on y-axis we have the demand of the product or the sales of the product, and the demand of the data over the time is basically fluctuating against a certain average value. So as you can see that it is basically moving around the average value of the data. Okay, or you can say the mean value of the data, so which is indicating that it is a level data. Okay, whereas if we have the trend, so that means we might have the data trend is going to be the increasing, or might be possible we have the trend in decreasing. So that means over the time either the demand of the product is increasing or decreasing. So the trend could be increasing or decreasing. So whereas the seasonality means that mean we are basically for a certain time period, okay, every certain time period we are observing the regular pattern of the data. As you can see that from the first time period the demand is increasing, but after the third time period it is going to be decreased and then again increase. So this is indicating basically the seasonal pattern in our data, so which is repeating over the time. Okay, so remember that as far as the forecasting method is concerned, we have to identify whether our data is containing the only the level pattern or whether our data is containing level plus trend pattern, which mean it is having the level pattern is always there and it is having the trend or not. If it is having the trend, then we are going to apply such a forecasting method which should cover level plus trend pattern. But if the data pattern only having the level pattern, then we are going to apply such forecasting method which can predict only the level pattern of the data. Okay, but if our data having the level plus trend plus seasonality, then we are different forecasting methods we have. So there is a data where is might be possible we only having the seasonality and the level component. Okay, there is no trend. There is might be possible we have level plus trend plus seasonality. So remember that the level component is always there, no matter we have the trend or we have the seasonality. So we have to predict the level part, then we will see is there any trend or is there any seasonality. So we are going to include that part as well in the forecasting in order to predict the future. So there is a fourth pattern as well, which is called as a cyclical pattern, which basically we are not using in the forecasting part, which is basically indicating the long term effect of the demand of that particular product or services. Okay, but in the forecasting part we mainly using these three components. Okay, as well as if we talk about the trend and the seasonality part, so the relationship between this trend and seasonality could be the additive or could be the multiplicative. What does that mean is, so if we are seeing the trend and the seasonality having the additive effect, okay, so the additive mean, so you can also add over here is the level part as well. So as I mentioned earlier, whenever there is a trend and seasonality, level is there. Okay, so remember that thing. So additive means the same pattern we are observing again and again. Okay, so that means what happened in the previous, the same pattern is going to be happen in the next time period. The same happen is going to be the next time period. Okay, so that is the additive, which mean every year or every month, like if I'm giving the example with respect to the monthly basis, that let's say in 2024, the demand which occur in the month of January, February, March up to December, the same pattern is going to be in the month of January to December in 2025. Okay, so that means the same pattern, that's why we are saying that we are going to adding it. Okay, but the multiplicative is when it is increasing in a multiplicative way, like as we can see that from here the demand is might be increasing two times or a three times. Okay, so the multiplicative effect, so it is we are saying two times is increasing or a three time is increasing, might be in general we can say n time is increasing. So over here it is we can say once again we have the multiplicative effect. If I am saying from here to here it is two time increasing, so from here to here it is also two times increasing and so on. So this is called as a multiplicative effect. Okay, so it is increasing. So once we are going to apply the forecasting method, we will see that whether the trend or the seasonality having the additive or the multiplicative. So based on that, we are going to apply the appropriate forecasting method. So in order to segregating this level component in your data, trend component in your data, and seasonality. This is called as a time series decomposition. Okay, in order to identify the every particular component in the pattern of your data, right? Okay, so before discussing different type of forecasting methods, as I mentioned earlier that so a good forecasting method is a such forecasting method which is basically producing smaller and smaller random variation, which means smaller and smaller errors. So before discussing those forecasting methods, let's discuss what are the error methods which we can use in order to check whether that particular forecasting method is good or not. Okay, so we have multiple type of forecasting accuracy methods, or you can say measure of forecast errors methods. Okay, one is called as mean absolute error, or it is also known as mean absolute deviation, where the formula for this one is AT. AT is basically indicating the actual demand, or you can say the observed demand, or the observed sales, or you can say the actual value in that time period, whereas FT is the forecasted value based on that time data. Okay, so T is basically the time indicating the time period. So we are saying that sum T from 1 to T, the absolute value of the error. So basically AT minus FT is basically the error value. Okay. So error in that time period is going to be the actual demand minus the forecasted value. Okay. So once we get the error, we are going to take the absolute, which mean we are always going to in order to calculate the mean absolute error, we are going to take the absolute value. Okay, whereas the second is, so this capital T is basically indicating the number of time period we are using in order to calculate that forecast error. Okay, so this is the mean square error, where instead of the modulus we have the square, we have a root mean square error. So this is basically nothing but taking the square root of this mean square error. We have the mean absolute percentage error, which is basically the modulus of AT minus FT over modulus of actual value. Okay, and then divided by sum of T multiplied by 100. Okay, one thing which is important over here, all these are the scaled measure of forecast error accuracies, or the forecast error methods. So what is the scaled mean? Scale mean it is that depending upon the data unit. Okay, is the data is the historical data is in kgs, or the historical data is in pounds, whatever the unit may be, in millimeter or inches. Okay, maybe weather temperature. Okay, so that means these methods are going to give us these forecasting errors in the result of that particular unit's forecast error. Okay, maybe in kgs, basically we are getting the forecast error, or in pounds we are getting the forecast error. So depending upon what kind of unit of that data have. Okay, whereas the mean absolute percentage error is a scale independent, which means it is not bothering about what is the unit. It is always giving us in terms of the percentage, or in terms of the ratio it is going to give us the answer. Another important thing regarding the mean absolute percentage error is that your actual data do not have any zeros in the data. Okay, remember that one. If your actual data having the zeros, then this method is not a good measure of forecasting error, because if we are going to divide the certain value with the zeros, it is going to be infinity. Okay, so that's why this method is going to be fail if you have in your actual data there is a zero. So in that case, do not apply this method. Okay, so how we are going to interpret? So smaller these values are, better the forecasting method. Okay, but there is no particular benchmark, is obviously as closer to the zero, better the method is. Okay, so once again, one more important thing is, while selecting the forecasting method, we are always going to take two or three these forecasting accuracy methods, and based on those, the combination of two or three, we are going to pick the best forecasting method, that which method is providing the smaller mean absolute error, which method is providing the smaller mean square error or mean absolute percentage error. Okay. Okay, so remember that while we are predicting, as we are saying that we are going to get the error based on the actual data and the forecasting error, forecasted data. So as for the forecasting, so we have to see that how much time in the future we are going to predict, whether we are going to predict one period ahead, or whether we are going to predict two period ahead or a three period ahead. So this one period ahead, two period ahead is known as, that period is called as the forecast horizon. So the most important thing is, smaller the forecasting horizon is going to give us the lesser forecast error. Longer the forecast horizon is going to generate more and more forecast error. Okay. So I hope you got this important point. Now the question is, how we can apply these measures of forecasting errors. So for that, I'm going to take this example. So let's say we have the previous year's monthly data. So we have the actual data and we have applied certain forecasting method. And based on our forecasting method, it is saying that the forecasted value of the January is this one. Okay, whereas the actual demand was this one. So now I would like to see how good this forecasting forecasts are. Okay. So in order to do that, we are going to first of all, so basically I am applying all these methods. So first of all, we are going to calculate the error. So as we know that the error is the actual demand minus the forecasted value. So this is the actual demand. This is the forecasted value. Okay. So this is going to be 437 minus 798. Similarly, we have 605 minus 807 and so on. Okay. And then the next column we are going to calculate, which is absolute error. So why we are calculating this one? Because over here we needed the absolute error. So the absolute error is nothing but taking the modulus of this error. Okay, that is modulus of 437 minus 798, which is mean we are going to take the positive value. Okay, similarly we are going to take the positive value, positive value, positive value, and so on. So after taking the modulus, what is the error? Okay, and then we are going to calculate the error square. So why we are calculating error square? Because error square is going to be used in mean square error as well as the root mean square error. So for that, how we can calculate the error square? So we are going to take the error square. So which means 437 minus 798. So whatever the value is, we are going to take the square. So this is the error square. Similarly, 605 minus 807, and we are going to take the square and so on. And then we are going to calculate the absolute percentage error. What does that mean? We are basically calculating this part. Okay, so which means we are going to take the absolute error value. So whatever the value we are getting over here, so we are going to divide that one with the actual demand, that is 80. Okay, so which means, so this is going to be modulus 437 minus 798 divided by modulus of actual demand, which is 437 multiplied by 100. So we are going to get the absolute percentage error. Same is the case in a second scenario. This is going to be modulus 605 minus the forecast is 807 divided by modulus of 605 multiplied by 100 and so on. Okay. So once we calculated this absolute error, we calculated error square, we calculated absolute percentage error. What we now need to know is, we are going to sum these values and divided by the number of time periods we have. So basically, we are going to take the average of this one. So sum this one and then divided it with the number of values. So number of values we have, that is the 12 in this case. So based on that, we are going to get from this column is the mean absolute error after taking the average, which means sum of all these divided by 12, we are going to get the mean absolute error. sum of all these divided by 12, we are going to get the mean square error. And if we are going to take the square root of this one, we are going to get the root mean square error. And if we are going to take again the sum of these divided by 12, that is the number of time period, we are going to get the mean absolute percentage error. So after solving it, so we are getting this one. Okay. So over here, how we are going to interpret, again, smaller these values, better this forecasting method is, right? So let me apply in the Excel. Let me show you the same example in the Excel. So how we have done is, this is the actual demand. This is the forecasting value, as I mentioned earlier, that the actual demand minus the forecasting value after applying it one. This one, like, this is the actual demand minus the forecasting value, and then we can drag and drop. Okay, so we have calculated the forecasting value against the every value, and then we have a function called abs, which is called as the absolute of this error. Okay, so once again, we can, after applying the on the first cell, we can drag and drop, and then we have the error square, so equal, we have this error cell, and then take the power 2, which is the square. Okay, and then we can drag and drop. Okay, and then what we are going to do is, we are going to take the percentage value. Okay, so equal, so this is the absolute error divided by the actual demand. Okay, and if I am saying, we are going to drag and drop, and how we are getting this percentage, if I am going to take select this value in terms of percentage, right? So, and then you can call it reduce up to after decimal how many. So I am saying that after decimal, we are going to take up to 0 level. Okay, so that's why. So if you want to take up to 1 level, so you can increase this one. Okay, so once we have calculated this absolute percentage error, now we can take the average value. So average of these absolute error is going to give us mean absolute deviation, or you can say the mean absolute error. So this is the average of this error square is the mean square error, and then once again the average of this one is going to be mean absolute percentage error, and then this one is the square root. So this is basically equal square root of this mean square error. So we are getting all the answers which we have find over here. Okay. So I just rounded it out. That's why you can see that this 185. Okay, so I hope you got the idea. Basically, while forecasting this fast demand time series, what thing we are going to see? Okay, first of all, we are going to see whether my data having only level, trend, or seasonality, or it is the combination of level or trend, or a level of seasonality, or it is the combination of all three, level, trend, and seasonality, as well as whether they have the additive relationship or a multiplicative. And then we start discussing about the forecasting accuracies methods. Okay, so thank you so much. See you in the next video.